Hello, I'm Steve Hill, Digimania's Technical Support Manager. In this video, I'll be showing you some of the advanced features of RenderDigimania. I'll explain the difference between static and dynamic lighting, how to use light channels, how to animate using RenderDM's keyframing tools, how to set up render layers and render passes, and how to create materials. We'll start off by opening the scene file we saved at the end of the last tutorial. It's got all the sportsman assets in, plus a camera and a directional light. Make sure your project directory is still set to sportsman, and then open up tutorial_1.rdm. If you don't have the right project set, then the scene file won't be able to find the packages we made last time. The first thing we want to do is adjust the ambient lighting of the scene. Ambient lighting is controlled by a skylight, which is a hemispherical dome of light simulating scattered light from the sky. Go to the Scene panel over here on the left and click on Skylight. The skylight properties will appear in the Properties panel on the right. There are two ambient light brightness settings here. Upper brightness controls the light from above, and lower brightness controls the light on the lower surfaces of objects. Reduce both of these values to 2% to give the scene a darker look. The shadows now stand out a lot more, and you can see that the shadow cast by the sportsman is much sharper than the one cast by the roof. To make these shadows match, we need to adjust the environment properties. Select Environment in the Scene panel, then over in the Dynamic Lighting properties, increase the shadow sharpness to 97%. Now let's add another light. Click on the Create Light icon on the toolbar and select Point Light. Use the Move manipulator to put the point light in front of the sportsman's head and slightly to one side. Go to Properties and increase the brightness to 10%. We're now going to split our lighting into static and dynamic. This is what the SD label next to the point light means. Dynamic lights are real-time lights. They're used to illuminate any object that can move or deform over time. Static lights, on the other hand, are pre-calculated and are used to illuminate background objects which don't move. They provide the advanced lighting effects such as ambient occlusion and global illumination. The illumination and shadow produced by static lighting gets baked into special textures called light maps, which are applied to statically lit objects using their UV coordinates. To make a rigid mesh like the arena receive static lighting, select it and set Receives Lighting to Static from the drop-down list. Do the same for the roof, but not for the crate. Skeletal meshes, such as the sportsman, can't receive static light, and so there's no static lighting option in the sportsman's properties. Select the directional light and reduce its brightness to 5%. Untick the Affect Dynamic Objects option. Now it will only illuminate static objects like the arena and the roof. The SD label next to the light will change to just S, showing that it only illuminates static objects. The crate mesh has become darker, but the sportsman, arena and roof meshes are unchanged. The crate isn't illuminated by the directional light anymore because the light is now static and the crate can only receive dynamic light. Now select the point light and make it dominant. The light's label will change to SD DOM. A dominant light is the only type of light that can cast dynamic shadows onto static objects. There can only ever be one dominant light in a scene. Next, we've got to check that the light map resolution is good enough for each mesh. This will depend on the mesh's location in the scene. Large foreground objects will need higher resolution light maps than small background objects. If the resolution is too low, then the light map will look pixelated. If the resolution is too high, then the processing will take too long. Open the project library and double-click on the thumbnail for the Arena Rigid Mesh. This is the Rigid Mesh editor. It lets you see a 3D preview of the mesh. There are similar editors for skeletal meshes, materials and textures. Change the light map resolution to 1024 using the drop-down list on the right. Click on the Close button to close the editor. Repeat these steps for the roof mesh. We're now ready to build the static lighting. This is where the static lighting effects will get baked into the light maps. Go to Lighting on the menu bar and select Build Static Lighting. Leave the settings at the default values and then click on the Build Static Lighting button. This will take about a minute at default quality. When it finishes, the shadows being cast by the roof onto the arena will be baked into the texture maps. If you select the directional light and rotate it, then these shadows won't move. Building static lighting is a one-off task. It doesn't depend on the length of the animation or the camera motion, and it helps to make the final render faster. The lighting of the arena and the roof has a slight blue tint. If you select the environment and look at its properties, then you'll see that the environmental colour is pale blue. The sportsman mesh is only affected by dynamic light, so let's give him a blue tint too. That'll keep the lighting consistent. Select the skylight and change the upper colour to pale blue. We can type in the hex value of 819 dBB. Now change the lower colour. The easiest way to do this is to click and drag the colour swatch for the upper colour over onto the lower colour swatch. The scene now looks consistently lit, with the exception of the crate. Let's create a light that will only illuminate the crate. Make another point light and move it to X-60, Y35, Z60. Change its colour to pale blue, that's 819 dBB again, and increase its brightness to 10%. Set the lighting to Affect Dynamic Objects Only. The SD label has changed to D. All dynamic objects will be illuminated by this new light, but it won't cast shadows on static objects. Rename this new light Crate_Light. Now go to the Lighting menu and select Light Channels. This is the Light Channels dialog. Here you can control your light linking. Untick all of the boxes in the Crate Light column apart from the crate. This will make the new light illuminate just the crate. Now we'll add a new camera to the scene and animate it using RenderDM's keyframing tools. There should already be a camera in the scene left over from the previous tutorial, so select it and delete it before adding a new one. Click on the camera button on the toolbar to create a new camera. There it is at the origin. Select it and set the translate values to x-60, y-170, z-25. Set the rotations to x0, y6, z287. And set the field of view to 50 degrees. We can see in the active camera view over here that the shot is now nicely framed. Now make sure we're at frame 1 on the timeline. In the camera properties panel, click on the small box to the right of the translate and rotate boxes. Select Add Keyframe. Down here in the timeline, a keyframe has appeared at frame 1. Go to the last frame of the sequence and move the camera over to the other side of the arena. Set the translate values to x70, y185, z70. Set the rotations to x0, y353, z250. Click on the Commit Changes button and another keyframe gets set. We can't really see what's going on where the camera panel is this small, so let's undock it and resize it. There now, that's better. Our final job before rendering is to split the scene up into separate render layers. Right-click on the sportsman and select Assign to New Render Layer from the context menu. Now go to the Render Layers panel. All objects are put in the background layer by default. However, we've just created a new layer called Render Layer 1 and assigned the sportsman to it. Right-click on the name, select Rename and call it Foreground. Let's put the crate mesh into the foreground layer. Click on the crate and drag it down onto the name. There we go. There's a small eye icon to the right of each layer. This controls the layer's visibility. Let's switch the visibility on and off to check that we've assigned the meshes correctly. We're now ready to render the scene. Click on the Render button. Naming the rendered images will be more complicated now because we've got 2 layers and we want to render several passes. Start by naming it tutorial_2. We'll need to include layer, pass and frame tags in the file name template to make sure that every rendered frame has a unique name. Set the frame size to 1920 by 1080. Make the output type either TGA or PNG. Select all of the render pass options. And change the rendering method to multi-pass shadows. This method takes longer than the default cutout layers. Instead of cutting out foreground objects from the background layers will be rendered with the holes filled. This lets you reposition the foreground elements if you need to. All of these layers and passes will make the rendering slower than in the last tutorial, so we won't render the scene right now. But when it finishes, you'll get 9 new folders in the destination you specified. There'll be folders for the foreground and background, beauty, diffuse, shadow and specular passes, plus a folder for the depth pass. You'll be able to rebuild the scene using these layers and passes in a third-party compositing app such as After Effects or Nuke. Close the render dialog. RenderDM will remember our settings for the rest of the session. Right then, the last thing we're going to do in this tutorial is fill the arena with water. Create a primitive cube by clicking on the Create Primitive button on the toolbar and selecting Cube. Use the scale manipulator to make the cube as big as it will go in X and Y and about as high as a sportsman's knees in Z. Open the Light Channels dialog and unlink Cube and Create Light. Open the project library and create a new package called tutorial_2. Highlight the tutorial2 package, right-click in the work area and select Create Material from the context menu. Select the water template from the drop-down list and name the material water_T2. Double-click on the Water T2 thumbnail and the material editor appears. Go to Displacement. Change Strength to 15%, Tiling to 50% and Panner Speed to 50%. This will add wave motion to the surface. Make sure that you tick Use Displacement, otherwise the wave effect won't be switched on. Now go to Distortion. Reduce Strength to 25%. This will reduce the simulated distortion of objects seen through the water's surface. Go down to Edge Texture. Change Edge Bias to 30%. Mask Tiling to 80%. And Mask Speed to 75%. This will add a line of spume around every object that intersects with the surface of the water. And again, make sure that you tick Use Edge Texture. Scroll down to the normal section of the properties. Change the Map 2 and Map 1 panning speed values to 50%. And the tiling values to 60%. This will increase the speed and frequency of the ripples on the surface of the water. In the opacity section, increase the depth to 70%. This controls the transparency beneath the water's surface. Save the new package, close the project library, then go back to the 3D scene and select the cube. In the Properties panel, click on the Material swatch and look in the Tutorial2 package. Select the water material that we've just created. And now the arena's full of water. So let's review what we've just done. We've split our lights and meshes into static and dynamic to save time in the final render. We've used light channels to control which light shines onto which object. We've created some simple camera animation. We've set up render layers and render passes. And we've created a new material based on one of RenderDM's templates. RenderDM gives us lots of control over how our scene is set up and how our render gets done, without compromising on speed. You'll find a full guide to all of our features at RenderDigimania.com in the support section. Thanks for watching. Feel free to send any questions to support@RenderDigimania.com.